Hello guys, welcome to the fourth part of our creating programming language together. And in the last video we were dealing with the expressions. So first thing I'm going to do here, it's rename this. I'm on the appendix class here, class not part of the book. So I was looking here, since we are going to implement the visitor, and all the class must extend from expression because they are an expression, so it makes sense. But this part here be here, okay, and on the classes here should extend from expression. Let's place here, okay. Let's see the classes we're going to need, which is assign. Create here the assign operation. Assign. Also binary expression, call expression. And the get, broken. The literal. Oh, I did group already. Let's move it to here. And grouping, literal, logical. Set expression. Have the super expression here. Not sure if I'm not going to use this one for now. Expression. Unary. They have verbal expression. Okay. And the expression one has the interface for the visitor, has accept. I was looking for the design pattern here for the visitor, since we need to have this virtual void accept. Finish this after implementing this. Okay, have it here. Let's go back here to the left here. So as you guys can see, all these extend from expression, and the literal accepts a string, a number, true, false, nil. Have grouping which accepts, let's see here, an expression, okay. Binary, an expression 2. Let's go to the binary you have done already, and the operator, since we don't have the operator here. There's no operator. Okay. Oh, because it's operator, it's a okay. So let's confirm here that token name expression value. Here. Okay. I have the binary, it's done already. Call expression. List of expression arguments. So let's create the column. We have the lead. We have int. They have a vector of expression. A vector vectors. We have std vector have expression object token name. Expression object token name. Enter. Grouping expression, which takes the expression. Okay, literal takes the value, logical left, operator right. Interesting, because it's very similar to binary one. Left E set expression, which takes expression, name and value. Name. Is dot name. Going to finish implement this and the implementation here, and I'll go back. Okay, so I have implemented the syntax.h here, as you guys can see. Just a note here to the self-expression. Let me show you here, which in the book it's called this. Okay. Have implement then here, so we can start to implement the visitor class. Okay, so let's go here to the book. Let's go down here and okay, visitor for expression. So in this is the script the author did to generate those functions here. The script basically generate this. So first I need to implement the class itself, but I'm not sure where to find it. Expression.visitor. Let me see here. So I have a class called visitor. Let's create it here then. Visitor. The accept function here will take a pointer to the visitor. Okay. And the onClass implements the the functions, the concrete functions. Let's see here. Returns the type. No idea where the visitor is being implemented. Okay, so did accept here the expression, so it can accept the visitor. Then we need to visit. We need to implement here the concrete here. Basically, what we need to do is, okay, we can visit sign question, and then we take a let's go here to the book. There's the book. Take a sign. Okay, I think this is the pattern. But I think it's a const. Yeah. Oops. Need to be constant. Not sure why. I think it should be this way. And okay, I have implemented this, so I need to implement the except for each one. Let's do it, for example, here. Void. Oh my god. Void. Accept. Const with visitor. So this one is not constant. Okay. Okay. Except a pointer to visitor. Right. Visitor. Visit assign expression. Yes. Okay. So I think this is the pattern. Okay. Not sure if I had to pass this to here, but I'll keep this way. For sake of simplicity, let's make it one line. Okay. So basically this is the pattern. Now I'll pause and implement for each expression here, and I get back. Okay guys, so I have found a way to solve the visitor problem. Okay, the first thing here, I renamed the syntax class to expression. Also, I renamed the other class to start with lowercase. And I created this, I defined the structs before the actual implementation. So we can we don't have compile problems. And here are the implementation in the visitor struct for each one of the types. Here they are, and here's how I've implemented. You guys can copy it if you're following along. Another thing I did was, let me show you. Just need to remember. Oh yeah, I have added a indent level here. Since our language is similar to Python and GDScript, we need to know which indentation level our script is. For example, here we have one tab, so the indentation level is 1. Okay, this is important. Let's go to the scanner here. As you guys can see here on the tab, I increment the indent level, and on line breaks I set it back to 0. So there's no black magic here, you know. So let's keep going. Also, I just renamed the symbol to forward arrow too. Okay, so we can keep continuing with our language. Okay, I've updated here the print, so we know the line and the ident level. Also, lines begins in 1 instead of 0. Let me show here. Here, line starts with 1, and in that level, current and starts begins with 0. Okay. Now let's continue here. We are doing a pretty printer now for the calculation because we need to have priorities. First thing here is create a ASC printer. Let's create here AST printer dot HPP. I think I will do HPP here because we do not need to split the file into 2. Okay, files. So the first thing is include the expression. Let's create a class here, class AST printer. Let's not forget to with a namespace. Namespace PPP. Okay, so we have a class here. Here the author is using implements, but let me check here. Let's create a public the string print fraction pointer fraction. be using return results. Okay, let's return expression except, and then we need to know which visitor it is. So let's go here to the scanner. No, it's to expression. Not sure if we make it static. Structure visitor static. Nope. Not sure if its field need to be. Let's check here. C++ static scope. Let's see. So the guy did here static script visitor. So I think this is possible. Plus expressions. Why did we ever? Static visitor static visitor. Let's make all of these inside of the class expressions. And smooth. Mm, expressions. Mm, First visible pattern. Thing here is that it has implemented the class for concrete visitors. Yeah. Starting to get very hard to deal with. Okay, guys, I think I've got how things work. Since we have in the example key here of the visitor pattern, since we have our visitor, we need to implement our custom visitor. So for example, here it's trying to access the visitor, but we need to create a struct here. Right. Let's make it private. Private. And we have here a struct called, for example, print visitor. Okay, let's make this way. And for example, the print visitor will extend from the visitor which we've made. Okay. And if you look here into the expression.h, we have functions to overload, you know. For example, let's overload the assign function, the assign expression here. No, the binary, which we are going to use now. So we just do, as you can see here, void visit, and you have the pointer to the type. So we can do the string visit, and we take the binary, for example, binary. Okay, let's see the error here. A tool type is not identical. Okay, so we can't have a different return type, which is strange. But we have here. So we put here attribute string name. We use void here. Okay, so we have overloaded it here, and the implementation will say that name it's equal binary. Turn the result here and expression expression accept est printer I'm going to make an instance of print is so we have to implement for all of the expressions here. So let me come in here. This will make errors, so we need to implement it. Let's copy this and paste it here. Okay, so I have implemented here for each one, so we can have an instance of it. So expression accept print little. Okay, identifier print visitor is undefined. Make it put here. Okay, so this pattern is very interesting, dude, because for example here we have implemented for the expression here. Okay, each one has this accept function, right? And when we call it, we pass the one we made here, so it will actually call this one, right? So for test, I think we can do a test. So for example, let's create here in the main function. Let's create this. Clear make run. Okay, it's compiling. So let's create an instance of the include est. Nope. Oh, found the problem. Yes, printer. Okay, so now we can make an instance of the printer. Then we can printer dot the what tests printer dot print, and we have to pass expression. The end line. Then we can I'm not sure if I need to include it expression because the HT printer already imported yeah. So let's create a binary expression here. No, let's create a logical which is simpler. Logical log. No default construct exists. Replace logical. Let's go here. Logical take two expressions. No, it's literal. Literal takes one string. So let's make literal, which takes a my 15 string. Oh, it's because it's a pointer to a string. You can pass the literal here. Okay. Let's make run. Redefinition. I think I'm having problems. Okay, guys, the problem is that I was including here the scanner. I was using namespace here. This was causing the errors. So I leave it only the AST printer, and here it is, the string, which is will be our literal. So we instantiate it here and point to our string, the address, and then we say printer.print our literal. Let's go here to the expression. As you guys can see here, the literal, the value of the literal expression is a string pointer. Let's go here to the implementation. So I gave a name, called it literal, and the variable name will turn the literal dot value. But the problem is that the literal dot value is a string pointer, and we want to convert it to a string, so we dereference it here. So whatever our literal is, it is going to print or print visitor.name, which will be literal.value. And as you can see here, our literal is hello world. So if we run, you guys can see that our literal gets printed. This is so cool, dude. Okay, let's get to the next step then. Okay, guys, now that we have implemented the visitor finally, next episode we are going to press an expression, which is chapter 6. And see you guys. Bye.